Okay, so today we're going to be looking at scales without units. Your goals for today: I can use scales without units to find scale distances or actual distances. I can explain the meaning of scales expressed without units. So up until this point, every time we've seen a scale, it's had units in it. So for example, this one has centimeters and meters. We've also seen there be inches used, but there's always been units. One unit is for the drawing and one is for the object it represents. However, sometimes scales are given without units. A map of a park says its scale is 1 to 100. What do you think that means? Give an example of how this scale could tell us measurements in the park. A map of a park says its scale is 1 to 100. The distances in this case could be in any unit, but because one is expressed as a number times the other, the unit is the same for both. So what the scale 1 to 100 means is that whatever we measure on the drawing, in real life, it's 100 times larger. So if we measure something on the drawing and it's 1 centimeter on the drawing, in real life, it is 100 centimeters. If we measure something on the drawing in inches, and we measure it to be 1 inch. In real life, it's 100 inches. If we measure it to be 5 inches, in real life, it's 500 inches. So 100 times bigger. And again, you have to use the same units for both, for the drawing and the actual measurements.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why 35 years ago fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard. Because that thing will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win. I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Neil Armstrong and Buzz Aldrin were the first people to walk on the surface of the moon. The Apollo lunar module was the spacecraft they used when they landed on the moon in 1969. So that spacecraft is pictured here on the top. The landing module was one part of a larger spacecraft that was launched from Earth. Predict. What size was the spacecraft? How would the height of a person compare to it? Here is a scale drawing of the Apollo lunar module. It is drawn at a scale of 1 to 50. The total height of the Apollo lunar module is about 23 feet tall. How tall would the Apollo lunar module be in the drawing if it were drawn to scale? Okay, so we're talking about a scale drawing, and they give us the scale without units. So again, as usual, we want to make our table. Drawing on one side and actual on the other. And the first thing we want to include on there is the scale they give us. They tell us 1 unit on the drawing is actually 50 times that in real life. Next thing we should be trying to figure out is how do we use our scale? So how do we go from 1 to 50? Well, we're multiplying by 50. And how do we go from 50 back to 1? That would be the opposite of multiplying by 50, the inverse of that, which would be dividing by 50. Okay, so we have our table, we know what our scale is, and we know how to use it. That means we know how to go from drawing to actual and actual back to drawing. They tell us the total height of the spacecraft is 23 feet tall. So we have to figure out, well, where do I put that information in this table? 23 feet tall, that is pretty tall. That is the actual height of the spacecraft. 23 feet. We want to know how tall this module should be in the drawing if it's drawn with this scale, 1 to 50. So for this one, we have to look at our arrows. We're on the actual side, which means we are dividing by 50. So 23 divided by 50. And when we do that, we get 0.46. So I'm going to go ahead and fill that out in my table. 0.46. Now, remember, this scale does not have units. So that means we have to use the same units for both the drawing and the actual. Since the actual is measured in feet, then my drawing units are also going to be in feet. So this drawing here of the spacecraft is 0.46 feet tall, which is about close to half a foot, which looks pretty accurate if you ask me. Next question. Same scale. Now it says the legs of the module on the drawing are about 2.75 inches tall. What is the actual height of the legs? So again, same situation. So we're going to make our table with drawing and actual. And then we have to fill in our scale, 1 to 50. And we should be filling in how we use that scale. Multiply by 50 if we're going from left to right, and then divide by 50 if we're going the other way, from right to left. They tell us the legs on the drawing are 2.75 inches tall. So that's a drawing measurement. So I need to put that on the drawing side. And that's measured in inches. And then you guys are going to use this scale to answer this question here. What is the actual height of the legs on here? Okay, so for this problem here, you had to multiply that by 50, right? Because we're going from left to right. And so you should have gotten 137.5. Since we started measuring in inches, our answer has to be in inches as well. All right, last one. I'm going to have you guys read through this one and work on this one on your own. Okay, so for this one, you should have still drawn your table, wrote down your scale, write down how you go back and forth using the scale. 71 inches, that's his actual height. So we had to divide that by 50 and we got 1.42. Since his height was in inches, the drawing height has to be in inches as well. Right, so that is Neil Armstrong next to the spacecraft. He's not even as tall as the legs of that spacecraft. So what does it mean when the scale on a scale drawing does not indicate any units? When a scale does not show units, the same unit is used for both the scale distance and the actual distance. For example, a scale of 1 to 500 means that 1 inch on the drawing represents 500 inches in actual distance. In other words, the actual distance is 500 times the distance on the drawing. To calculate actual distances, we multiply all distances on the drawing by the factor 500, regardless of the unit we choose or are given. So you always multiply it by 500 if that's the scale 1 to 500, and then you have to include the same units for both. How can a scale without units be used? How can a scale without units be used to calculate scaled or actual distances? So even though there's no units on there, it's still the same steps. You're still going to draw your table, drawing on one side, actual on the other side. You're going to write your scale in there. You're going to figure out, how do I go from drawing to actual and then back from actual to drawing. The only thing we have to remember is that when the units are not given to us in the scale, we have to use the same units for both.